You ever stop and wonder how a massive global system can be brought to its knees by something it didn't even know existed? Well, today we're going to explore how a really fundamental flaw in the way we track data created a crisis that sent ripples across the entire world. Let's dive in. So, picture this, a state-of-the-art factory, right? It's a marvel of modern engineering. You've got thousands of parts, hundreds of robots, all moving in perfect, beautiful sync. It's basically one giant global assembly line, a symphony of logistics that builds the world we live in. But inside that symphony, there's a single silent note. One tiny, almost insignificant component. A microchip, maybe a screw, or a simple plastic bracket. It just doesn't arrive. It's a part so small you'd think it was an afterthought. And just like that, the music ends. The entire, multi-billion-dollar operation grinds to a dead stop. Alarms are flashing, conveyor belts freeze, and the silence is deafening. And it's costing millions of dollars every single minute. Now, this isn't just some hypothetical scenario. This really happened. And that brings us to the big question. How could one tiny little part from a supplier the company didn't even know it was using cause such a total, catastrophic failure? The answer, it turns out, is buried deep inside a database. So let's look at the real-world case that really pulled back the curtain on this hidden weakness. Back in 2022, a major crisis slammed the auto industry, and it all started with what you could call a ghost in the machine. What's so fascinating here is the chain of failure. A huge automaker stops production, all because of one missing chip. The investigation traces it back, and it wasn't their direct, Tier 1 supplier. Nope. The problem came from a Tier 3 supplier, a company they had absolutely no record of. Even their main supplier had no clue this little workshop was part of their critical path. You see, this incident wasn't just bad luck. It exposed a massive systemic flaw. The problem wasn't really the part, it was the data. The databases that were supposed to be managing these incredibly complex operations had a giant blind spot, the invisible link. So, this is the key term we have to understand, a sub-tier supplier. Think of it this way. The big company pays its main or Tier 1 supplier. That supplier then pays a Tier 2 supplier for components, and that Tier 2 supplier might pay a little Tier 3 supplier for raw materials. To the company at the very top, those Tier 2 and Tier 3 vendors are, well, they're effectively invisible. And that right there, that brilliantly illustrates the core issue. Over the last few decades, supply chains just exploded into these vast, unbelievably intricate global networks. But the systems we built to see and manage them, they just didn't keep up. There was this dangerous lag between the complexity of it all and our ability to see it. To really get why this happened, we've got to look at the history of how these databases were actually built. You see, the blind spots weren't an accident. They were practically designed into the architecture from the very beginning. This timeline really shows how that gap developed over decades. We started with simple spreadsheets. Then, in the 90s, we got these big siloed ERP systems to manage our own inventory. By the 2000s, we developed portals to connect with our main Tier 1 suppliers. Now, each step was a huge leap forward, but do you see the pattern? We always stopped at that first layer, and that created the sub-tier visibility gap we're facing today. And there it is. That's the key. It wasn't just an oversight or some kind of bug. The fundamental architecture of these procurement and supply chain systems was never, ever designed to look past the companies we directly write checks to. It was a failure of imagination, and it was baked right into the code. This slide just perfectly contrasts the perception with reality. On the left, you've got this clean, simple chain that our databases were built for. But on the right, that's the messy truth, a tangled web of dependencies where some tiny, forgotten supplier in a corner can bring the entire network crashing down. So what happens when this gap between what we think is happening and what's really happening suddenly snaps shut? What's the actual tangible cost of all this untracked, invisible data? Well, the impact is staggering. We're seeing whole industries, like automotive and pharmaceuticals, just getting hammered by these failures deep in their supply chains. We've seen massive product recalls, millions in lost revenue, and delayed launches. And all this has triggered a response, a whole new wave of startups focused on mapping these hidden networks, and even governments are stepping in, pushing for laws that demand more transparency. At the end of the day, the greatest risks to these global companies were hiding in plain sight. They weren't some exotic, unpredictable events. They were failures from suppliers that were simply untracked, all because the data models were incomplete. So, what do we learn from all this? Well, the good news is that this problem is solvable. It just requires us to rethink resilience, not as a logistics problem, but as a database problem. And we have to rebuild it from the ground up. Here are the new rules of the road for building a truly resilient system. First, you have to map beyond Tier 1. You just have to. Then, you need to model the dependencies, not just make a list of vendors. You also have to start scoring the risk from those indirect suppliers. And most importantly, you have to treat this as a core database schema challenge. True strength really begins with knowing who builds the parts of your parts. This story is bigger than just factories and databases. It leaves us with a really provocative question to think about. In our own work, in our own lives, what are the invisible, untracked inputs that our entire world depends on? And what happens if one of them suddenly just disappears?